Alright class, today we're going to talk about one-to-one functions and inverse functions. So first thing we're going to do is, if you want to pause the screen and write this stuff down, I'm going to just talk through it real fast also. So actually, why don't you listen to me as I talk through it and then pause to write it all out. A one-to-one function is a function whose inverse is also a function. It means that each y value is unique as opposed to each x value, and you could use the horizontal line test to find if something is one-to-one. What is an inverse function? It's obtained by reflecting with respect to y equals x. You can also solve it algebraically by switching the x and y values and then solving, or the variables and then solving. And finally, to graphically to graph an inverse, all you do is switch the x, y coordinates or reflect it over the line y equals x. Okay, so why don't you guys pause the screen to keep writing this stuff down, and then unpause and I will move on. Alright, here we go. So, example 1 says find the inverse algebraically. So again, like I was saying, algebraically, you have to switch the x and the y. So here's the x, and f of x is like y. So now I write this is x equals 3y plus 4. Once you switch them, now you just have to solve for y. Subtract 4. And then we get y is equal to x minus 4 all divided by 3. But remember, we want to write it as inverse notation, so instead of y we're going to write the inverse of the function is x minus 4 over 3. So once you solve for y, just change the y back, except for change it into f inverse of x. Alright, let's try it again. That's going to become my x, that's going to become my y. So x equals y squared minus 4. We're going to move the 4 over by addition, so we get x plus 4 is equal to y squared. To solve for y, we have to take the square root of both sides. When we do that, since there's no restrictions, we get y is equal to plus or minus the square root of x plus 4. And then since this is an inverse, we're going to say that it's f inverse. And that's it. Okay, let's do one more. Well, if you want to try it first, pause the screen now and then see if you get it. Otherwise, you can follow along. We have this is now x, that's now y, so x equals 3 over y. Remember, when you have a y on the bottom, you have to multiply by y to get it out of there. So we get xy is equal to, these cancel, 3. So now we solve for y, and we get 3 over x, which actually is the exact same thing as the original. So the inverse is also 3 over x for this problem. And that happens with reciprocal functions. Okay. So that is solving by switching the x and y and then solving for y. Now, to sketch a graph. And these tick marks are a little off in terms of the numbering down here. To sketch a graph, what's easier to do is to write down what points you have on the original. So for f of x, I have the points 5, 9. Is that 5, 9? Yeah. I have the point 2, 4. I have the point negative 2, 2. I have the point negative 3, 0. And I have the point negative 8, negative 3. So those are just points that are on this red line. Now I need to graph the inverse. To do that, all you do is switch the x and y's. So now it's 9, 5, 4, 2, 2, negative 2, 0, negative 3, and negative 3, negative 8. So if I do that, I can now plot these new points in blue, 9 up to 5, 4 up to 2, 2 down to negative 2, which is that one actually. 0 down 1, 2, 3. That's why I'm saying going this way it doesn't match up with the numbers. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so those are my new dots. If I connect the lines with straight lines, dots with straight lines, I should have the graph of the inverse. And then notice, so that is the inverse. And notice the line y equals x goes through these corners here. And these ones as well. That should look like a reflection over that green line. So it does. Alright, if you want to pause the video to try this one on your own before I do it, you can right now. Otherwise, you can follow along. Alright, so the initial points on this one are 3, 7. Now this point here is 1, -2. This is actually -1, 2, 3, 4, 5, 6. It looks like -5, but it's -6. Again, the numbering going down is not correct. And this is -4, -8. So we switch the points up. We get 7, 3, -2, 1, -6, 0, and -8, -4. So now I graph 7, 3, -2, -1, -6. Oh, sorry, that's -2, 1. That didn't make sense to me. I was like, why is the next point lower? -6, 0, and -8, 1, 2, 3, 4, -4. So if I graph and connect the dots and kind of make it look like that one, sure enough, it looks like it was reflected over the line y equals x. Okay? So that's how you do that with graphing. The last thing we're going to talk about today is how you verify if two functions are inverses. Well, basically, if you have f of g of x, and you get x, and you also have to do g of f, and you also get x, then they are inverses. To write it in the old way, that has to equal this, which has to equal x. So we're doing our two composites from yesterday, and we're going to see what happens there. So we basically know the answer has to be x. So pause the screen if you need to write that again. Otherwise, we're going to keep going. So the first thing I need to do is do one or the other. I'm going to do f of g of x, which means I have f minus 3, and where I have an x, I'm going to put g of x in. So I have 1/4 x plus 3. Okay. Now I just have to simplify this. The easiest thing to do is cancel these out right away, because if you distribute the 4 to the 1/4, it's gone, and you're left with x plus 3 minus 3, which then is x. And you do have to show your steps. Don't just say, oh, it's x. I want to see the algebra. That's what I'm grading. G of f of x is, we start with g, 1/4, parentheses, we have a blank, plus 3. What goes into that blank? It's now 4x minus 3. So first thing you should do is simplify the inside, which is just 1/4 on the outside, and then 4x, which again is just x. So we have just verified that they are inverses because both composites are equal to x. Let's do it one more time. This time, this is just telling you the domain of the problem and the domain of the problem. It doesn't matter for this part here. So if I do f of g of x, I have x as my outside one, so then there's a blank plus 1 squared. What am I putting in that blank? I'm putting g of x in. Root x plus minus 1. So if you notice inside here, these cancel, so we're left with square root of x. The 1's cancel, I should say, not these. And we're left with square root of x squared, which turns that just into x, so that is good. Now we have to do it the other way, g of f of x. So g of f of x, we have g as the outside one, which is the square root of something minus 1. What are we putting in that x spot? We're putting an x plus 1 quantity squared. So what happens here is the square and the square root do cancel out because it's one piece being squared and square rooted. So you get x plus 1 minus 1, which simplifies to x as well. Alright, so next we're just going to talk about what happens with domain and range of f of x and its inverse. So if you notice, if I graph f of x, I'm going to just sketch a graph. It helps us find the range. This is moved left 1, and I only want and it actually tells you the domain of both of these. So I move left 1 and I want this branch. If I graph the inverse, that's the square root function that is moved down 1, and it looks like that. I only want that branch. Okay. So now I want to know the domain and range. So I have f of x and the inverse. I have the domain and the range. For the function, I tell you the domain is x is greater than or equal to -1. And for this function, I tell you the domain is x is greater than or equal to 0. So usually for range, you have to look at a graph. Let's look at the original functions graph. It starts at a y of 0 and goes up forever. If you look at the inverses graph that I graphed up here, it starts down at -1 and goes up forever. So you get y is greater than or equal to -1. What you should notice here is that the domain of the original is the range of the inverse and vice versa. So the domain of f of x is the range of f inverse of x, and vice versa. So now what's good about that is if you have problems on your homework and you can find the domain of both of them, you don't have to do anything with range except for swap them. You don't have to graph it, you don't have to figure it out. You just have to figure out the two domains, and then you have the ranges. Alright, so that is inverses and one-to-one functions.